This is the EdExcel A-Level Maths Paper 2 from the 2021 series covering the pure maths content. Question number 1. In an arithmetic series, the first term is 16 and the 21st term is 24. For part A, we have to find the common difference of the series. We know so far un is equal to a, the first term, plus n minus 1 multiplied by d, the common difference. We know that the first term, a, is 16 and the 21st term is 24. If we substitute these conditions in, we have u21, which is equal to a, 16, plus 21 minus 1 multiplied by d, and this is equal to 24. The 21st term is equal to 24. And we need to solve for d. If we attempt to solve for d, 24 minus 16 divided by 20, that gets us 0.4. So d, the common difference, is equal to 0.4. Now for part B, hence find the sum of the first 500 terms of the series. For part B, to find the sum of an arithmetic series, we have Sn equals 1/2 n multiplied by 2a plus n minus 1 multiplied by d. We need to find the sum of the first 500 terms. We need to find S500. So S500, this is equal to 1/2 multiplied by 500 multiplied by 2a, so we've got two lots of 16, plus 500 minus 1 multiplied by d, which we know is 0.4. So if I find out what S500 is, we have 1/2 times 500 times by 2 times by 16 plus 500 minus 1, lots of 0.4. It turns out S500 is equal to 57,900. Question number 2. The functions f and g are defined by f of x equals 7 minus 2x squared, where x is a real number, and g of x equals 3x over 5x minus 1, where x is a real number and x doesn't equal 1/5. For part A, we have to state the range of f. To begin with, it will be a good idea to sketch f. Here you can see we have the graph of y equals f of x. Now, to find out the range, what we need to do to begin with is find out where the graph intersects the y-axis. We can do that by finding f of 0, and of course f of 0 is just equal to 7. So the point over here has coordinates 0, 7. And so therefore, for the range, you can see we have everything below and including 7, and so therefore we have f of x is less than or equal to 7. Of course, here we would include the less than or equals to symbol because we include the 7 with it, and it's everywhere below this point here. Now for part B, we have to find g of f of 1.8. The first thing we can do is find out what f of 1.8 is, and then find g of that result. So for part B, let's begin by finding out what f of 1.8 is. F of 1.8 is equal to 7 minus 2 lots of 1.8 squared. So if we work this out, 7 minus 2 lots of 1.8 squared, that's equal to 0.52. And so therefore, g of f of 1.8 is the same as working out g of 0.52. In other words, if we take a look at what g is, we need to replace the x with 0.52. And if we do that, g of 0.52, we have 3 lots of 0.52 over 5 lots of 0.52 minus the 1. So we've got 3 lots of 0.52 over 5 lots of 0.52 minus 1, which is equal to 0.975. And now for part C, we have to find the inverse function of g. Well, to find the inverse function, we replace g of x with y. And if we do that, we have y equals 3x over 5x minus 1. Our second step would be to rearrange for x. So, if we rearrange for x, first thing, let's multiply through by 5x minus 1. We have y lots of 5x minus 1 equals 3x, expanding 5xy minus y equals 3x. Everything involving an x on one side, everything that doesn't involve an x on the other side. We have 5xy minus 3x equals y. Factorize out an x. So we have x lots of 5y minus 3 equals y. Divide through by 5y minus 3, leaving us with x equals y over 5y minus 3. Our third step would be to swap x and y. So we have y equals x over 5x minus 3. Our fourth step would be to replace y with the inverse of g. So we can therefore conclude that the inverse of g is equal to x over 5x minus 3. Question number 3. Using the laws of logarithms, we have to solve the equation log base 3 of 12y plus 5 minus log base 3 of 1 minus 3y equals 2. The first thing we can do is use the subtraction law of logs on the left hand side. Of course, you'd find we have the same base, so that's possible. Doing so, we have log base 3 of 12y plus 5 over 1 minus 3y. And this is equal to 2. We now need to antilog both sides. And if we do that, we end up with 12y plus 5 over 1 minus 3y. And this is equal to 3 to the power of 2. And recognizing that 3 to the power of 2 is equal to 9, and multiplying through by 1 minus 3y, you can see then we have 12y plus 5 equals 9, same as 3 squared, lots of 1 minus 3y. If we expand, we end up with 12y plus 5 equals 9 minus 27y. So 39y is equal to 4, from which we can conclude y is equal to 4 over 39. Question number 4. Given that theta is small and measured in radians, we have to use the small angle approximations to show that 4 sine of theta over 2 plus 3 times by cosine theta squared is approximately equal to 1 plus b theta plus c theta squared. Well, with the small angle approximations, we know that sine theta is approximately equal to theta, and cos theta is approximately equal to 1 minus theta squared over 2. Let's begin by copying out what we have on the left hand side. We have 4 times by the sine of theta over 2 plus 3 times by the cosine of theta squared. Now, if we were to use the small angle approximation for cos theta, cos theta squared will be approximately equal to 1 minus theta squared over 2 all squared. We'd end up with a theta to the 4 at some point. And here we've only got a theta squared. So let's replace the cosine theta squared with an appropriate identity. What this is equal to is 4 sine of theta over 2 plus 3 multiplied by 1 minus sine squared theta. And so if we use the small angle approximations, we have 4 lots of theta over 2 plus 3 lots of 1 minus theta squared. Of course, sine of theta over 2 is approximately theta over 2, and sine squared theta is approximately theta squared. And now we need to expand and simplify all of this. 4 times by theta over 2 is 2 theta. We then add on 3 and then subtract 3 theta squared. So, using the laws of commutativity, we have 3 plus 2 theta minus 3 theta squared. In other words, A is equal to 3, B is equal to 2, C is equal to minus 3. Question number 5. The curve C has equation y equals 5x to the 4 minus 24x cubed plus 42x squared minus 32x plus 11, where x is a real number. For part A, we have to find the first derivative, dy over dx, and the second derivative, d squared y over dx squared. Given the curve C, the first derivative, dy over dx, that's equal to 20 x cubed minus 72 x squared plus 84 x minus 32. For the second derivative, d squared y over dx squared, we have 60 x squared minus 144 x plus 84. Now, for the first part of part B, we have to verify that C has a stationary point at x equals 1. Well, of course, for a stationary point, we require dy over dx to equal 0. So, dy over dx equaling 0 can be shown by substituting x equals 1 into dy over dx. When x equals 1, dy over dx is equal to 20 lots of 1 cubed minus 72 lots of 1 squared plus 84 lots of 1 minus 32. 20 minus 72 plus 84 minus 32, you'd find this to equal 0. We can therefore conclude we have a stationary point at x equals 1. Now, we have to show that this stationary point is a point of inflection, giving reasons for your answer. What we would have to do for the second part of part B, to begin with, let's test out what the value of the second derivative is when x equals 1. When x is equal to 1, d squared y over dx squared, we have 60 lots of 1 squared minus 144 lots of 1 plus 84. If we work all of this out, we've got 60 lots of 1 squared minus 144 lots of 1 plus 84. Turns out we get 0. And then, choosing points either side but very close to x equals 1, for example, x equaling 0.8, d squared y over dx squared, we have 60 lots of 0.8 squared minus 144 lots of 0.8 plus 84. So 60 lots of 0.8 squared minus 144 lots of 0.8 plus 84, we end up with 7.2. 7.2 is of course greater than 0, and therefore here we have a situation where we have something which is convex, and when x equals 1.2, say, d squared y over dx squared, we have 60 lots of 1.2 squared minus 144 lots of 1.2 plus 84. If we work out what this is, we get minus 2.4. The value here is less than 0. We have a situation where we have the curve being concave. We are going from convex to concave. The stationary point is a point of inflection. Question number 6. The shape OABCDEFO shown in figure 1 is a design for a logo. In the design, OAB is a sector of a circle center O and radius r. Sector OFE is congruent to sector OAB, which means this and this are the same. OCD is a sector of a circle center O with radius 2r. And AOF is a straight line. Given that the size of angle COD is theta radians, for part A, we have to write down in terms of theta the size of the angle AOB. For part A, the size of the angle FOB, well, this will also equal the angle FOE. Of course, the triangles are congruent. We have angles on a straight line summing to 180, or pi radians. We take away theta, and then we divide through by 2. So that is the angle AOB, which is equal to the angle FOE. Now for part B, we have to show that the area of the logo is 1/2 r squared lots of 3 theta plus pi. The area that's equal to 2 multiplied by, well, the reason we've got 2 is because this sector is the same as this sector, and the area of this sector is equal to 1/2 r squared lots of the angle we've just worked out. So we've got 2 lots of 1/2 r squared lots of pi minus theta over 2, and then we add on the area of the larger sector. Well, the angle is theta, the radius is 2r, so we add on 1/2 lots of 2r all squared lots of theta. Two lots of 1/2 is 1, so we have r squared lots of pi minus theta over 2, and then 4r squared theta over 2 is what we will add on. And now we need to tidy all of this up. Well, let's expand. We have r squared pi over 2 minus r squared theta over 2 plus, well, here 4 divided by 2 is 2, so we have 2 r squared theta. So what we end up with is 3 r squared theta over 2 plus r squared pi over 2. And if we tidy all of this up, you can see then the area is equal to r squared lots of 3 theta plus pi all over 2. So this is what the area is equal to, exactly what we wanted to show. Now for part C, we have to find the perimeter of the logo, giving an answer in simplest form in terms of r, theta and pi. For the perimeter, the perimeter P, well, the length over here, r, is the same as this length over here, also r. To work that out, of course, 2r minus r gives r. So we've got 1, 2, 3, 4 lots of r. And then the arc AB is equal to EF. So to work out what that is, we have the radius multiplied by the angle twice because we have AB equaling EF. So we add on 2r lots of pi minus theta over 2. And then the arc length of CD, that will be 2r theta. Of course, the radius of that is 2r. We multiply it by theta. So if we work out what this is, we have 4r. 2 divided by 2 is 1. So we add on r lots of pi minus theta, and then we've got 2r theta. We now need to simplify all of this. We have 4r plus r pi minus r theta plus 2r theta, which is equal to 4r plus r pi plus r theta, and then factorising out an r, we have r lots of 4 plus pi plus theta. So this is what the perimeter is equal to. Question number 7. In this question, you should show all stages of your working. Solutions relying entirely on calculated technology are not acceptable. We have figure 2, which shows a sketch of part of the curve C with equation y equals x cubed minus 10x squared plus 27x minus 23. The point 5 minus 13 lies on C. That's what we see here. And the line L is a tangent to C at P. For part A, we have to use differentiation to find the equation of L, giving your answer in the form y equals mx plus c, where m and c are integers to be found. We know what y is. For us to find out what the equation of the line L is, we need the gradient and a point which the line passes through. We can find out the gradient of the tangent at the point P through differentiation. For part A, we begin with y equals x cubed minus 10x squared plus 27x minus 23 dy over dx, that's equal to 3x squared minus 20x plus 27, when x is equal to 5, dy over dx. If we work out what this is, we've got 3 lots of 5 squared minus 20 lots of 5 plus 27. If we work out what this is, 3 lots of 5 squared minus 20 lots of 5 plus 27, it turns out we get 2. So this 2, it represents the gradient of the tangent. Now we know that the line passes through the point 5 minus 13. So the equation of the line L, that's given by y minus 13 equals 2 lots of x minus 5. And so therefore, for the equation of L, we have y equals 2x minus 23. Now for part B, hence verify that L meets C again on the y-axis. Well, you can see over here we have the point 0 minus 23. When x is 0, y is minus 23. When x is 0, y is minus 23. And so therefore, for part B, both C and L pass through 0 minus 23, and so C meets L again on the y-axis at this point here. Now for part C, the finite region R, shown shaded in figure 2, so that's this over here, is bounded by the curve C and the line L. We have to use algebraic integration to find the exact area of R. Well, to find out the area of R, hopefully what you can recognize, we have a trapezium. So what we can do is find out the area of the trapezium, and then we can find out the unshaded region, and subtracting that will allow us to find out the area of R. You can see here we have a trapezium. The height here, 5 minus 13, the height here therefore is equal to 13. The height here, well, 0 to minus 23. The height here is 23. We are going 5 across. So to begin with, the area of the trapezium, we have 1/2 lots of the sum of the parallel sides, 13 plus 23, multiplied by 5. So the area of the trapezium, we've got 1/2 multiplied by 13 plus 23, lots of 5, which is 90. What we can now do is find out the unshaded region. The area of the unshaded region, let's just show that in blue. We can find through integration. The area of the unshaded region, of course, we'd have to integrate. We will be integrating what y is, which is x cubed minus 10x squared plus 27x minus 23 with respect to x in between x equals 0 and x equals 5. So, if we work out what this is, we have 1/4 x to the 4 minus 10 over 3 x cubed plus 27 over 2 x squared minus 23x, which needs to be evaluated in between 0 and 5. So, for our upper limit, we've got 1/4 lots of 5 to the 4 minus 10 over 3 lots of 5 cubed plus 27 over 2 lots of 5 squared minus 23 lots of 5. For our lower limit, of course, we just have 0. So if we work all of this out, we have 1/4 lots of 5 to the power of 4 minus 10 over 3 lots of 5 to the power of 3 plus 27 over 2 lots of 5 squared minus 23 lots of 5. We get an area of 455 over 12. Of course, we take the magnitude of this because we have area. And so therefore, the shaded area is equal to, well, we would have 90 minus 455 over 12. And if we work this out, we have 90 minus 455 over 12, which is 625 over 12. Units squared. Question number 8. The curve C has equation px cubed plus qxy plus 3y squared equals 26. P and Q are constants. For part A, we have to show that dy over dx is equal to ap x squared plus bqy over qx plus cy, where a, b and c are integers to be found. So for part A, we begin with px cubed plus qxy plus 3y squared equals 26. We have to differentiate. And if we differentiate, of course, we've got terms containing both x and y. We'd have to differentiate implicitly. Differentiating px cubed, we end up with 3p x squared. Differentiating qxy, well, here we'd have to use the product rule. Differentiating, we end up with qx times by the derivative of y with respect to x, which is 1 times by dy over dx. And then we add on y, lots of the derivative of qx, so we have qy. And if I differentiate 3y squared implicitly, we end up with 6y multiplied by dy over dx. And this is all equal to 0. The derivative of 26 is 0. If we now factorize and group like terms together, well, in terms of the dy over dx's, we've got qx plus 6y lots of dy over dx. And this is equal to minus 3p x squared minus qy. And therefore, if we find out what dy over dx is, we have minus 3p x squared minus qy over qx plus 6y. We have found out what dy over dx is in required form. Part B of the question. Given that the point P with coordinates -1, -4 lies on C, and the normal to C at P has equation 19x plus 26y plus 123 equals 0, we have to find the value of P and the value of Q. Well, we know that P lies on C. So what we can do for part B to begin with is substitute that point in. If we substitute in the point -1, -4, then we have P, lots of -1 cubed, plus Q, lots of -1, lots of -4, plus 3, lots of -4 squared. This is equal to 26. Let's tidy this up. We've got minus P, and then here we've got plus 4Q. 16 times by 3. And if we do 26 minus this, what we end up with is minus P plus 4Q is equal to minus 22. Now, we also know that the normal to C at P has equation 19x plus 26y plus 123 equals 0. With our formula for dy over dx, we can find out what the gradient of the tangent is, and then use that to find out what the gradient of the normal is. First of all, if we take a look at the equation 19x plus 26y plus 123 equals 0, we can rearrange this equation in the form y equals mx plus c. And if we do that, we would have y equals minus 19 over 26 x minus 123 over 26. So what can we conclude from here? Well, we can conclude that the gradient of the normal is minus 19 over 26. And so therefore, the gradient of the tangent is 26 over 19. Now with dy over dx, if we substitute in the point -1, -4 and equate this to 26 over 19, we can find another equation in terms of P and Q. So, replacing x with -1 and y with -4 and dy over dx with 26 over 19, at the point -1, -4, we have minus 3p, lots of -1 squared, minus q lots of -4, divided by q lots of -1 plus 6 lots of -4, this is equal to 26 over 19. So let's tidy all of this up. Cross multiplying, we have here -3 times 19, that's -57, and then -1 all squared, that's 1. So we've got -57p, and then here -4 times by -1 times by 19, that's 76. Q, this is equal to 26, well, this is equal to -26q, and then we've got -24 times by 26, which is -624. So if we add 26 to both sides, 76 plus 26, that's 102. So we have 57p minus 57p plus 102q, that's equal to 624. We have equation 1 and equation 2, which we can solve simultaneously to find out the values of p and q. So therefore, if we use the simultaneous equation solver on our calculator, for the first equation, we've got -1p plus 4 times by q equals -22. For the other equation, we've got -57p plus 102q equals 624. So we've got here -1p plus 4q equals -22, minus 57 plus 102. This is equal to 624. Rather here, we've got minus. So we get p equals 2 and q equals -5. Question number 9. We have to show that the sum from n equals 2 to n equals infinity of 3/4 to the power of n times by the cosine of 180n degrees is equal to 9/28. Well, here we've got a summation. Now, what we can do is see what sort of a pattern we'd have. Well, because we're multiplying and then adding everything together to infinity, this would suggest that we have a geometric sum to infinity. And if we take a look in the formula book, it suggests to us that we need to use this formula over here at some point. So what we need to find out is what a is, the first term, and what r is, the common ratio. How can we find out the first term? Well, the first term we can find out by substituting n equals 2. When n equals 2, we have 3/4 to the power of 2 times by the cosine of 180 times by 2 degrees. So 3/4 to the power of 2 times by the cosine of 180 times 2 we get 9 over 16. So the next term, when n equals 3, we have 3 over 4 to the power of 3 times by the cosine of 180 times by 3 degrees. And if we work this out, we get minus 27 over 64. And when n equals 4, we have 3 over 4 to the power of 4 times by the cosine of 180 multiplied by 4 degrees. So if I work out what this is, we end up with 81 over 256. And we could continue on. Now, what we can see from here then is A is equal to 9 over 16, the first term, and the common ratio, we can divide successive terms. We've got minus 27 over 64 divided by 9 over 16. We get minus 3/4 for r. So r is equal to minus 3 over 4. And knowing what our first term is and what the common ratio is, we can therefore conclude that the sum from n equals 2 to n equals infinity of 3 over 4 to the power of n times by the cosine of 180 times by n degrees, that's equal to, using the geometric series we mentioned here, 9 over 16 divided by 1 minus r. So we've got 1 minus 3 over 4. So if we work out what this is, we have 9 over 16 over 1 minus 3 over 4. It turns out we get 9 over 28. And this is our answer. Question number 10. The time t seconds that a pendulum takes to complete one swing is modelled by the formula t equals al to the power of b, where L meters is the length of the pendulum and a and b are constants. For part A, we have to show that this relationship can be written in the form log base 10 of t equals b times by log base 10 of L plus log base 10 of a. For part A, we begin with t equals a times by L to the power of b. If we take log base 10 of both sides, we have log base 10 of t equals log base 10 of a times by L to the power of b. And if we use the addition law of logs, we have log base 10 of a plus log base 10 of L to the power of b, from which we can conclude log base 10 of t is equal to b multiplied by log base 10 of L plus log base 10 of A. This is of the form y equals mx plus c. Now for part B, a student carried out an experiment to find the values of the constants a and b. The student recorded the value of t for different values of L. Figure 3 shows the linear relationship between log base 10 of L and log base 10 of t. For the student's data, the straight line passes through the points minus 0.70 and 0.21, 0.45. And using this information, we have to find a complete equation for the model in the form t equals al to the power of b, giving the value of a and the value of b each to 3 significant figures. Well, if we take a look at this diagram, what we can do first of all is find out the gradient. If we go back to our equation, you can see log base 10 of t, same as y, b, same as m, log base 10 of L, same as x, log base 10 of a, that's the same as c. So what we can do to begin with is find out the gradient, which of course is what b is. So for the gradient, we need the change in log base 10 of t's, and if we work out the change over here, this is 0.45, and the change in log base 10 of L from minus 0.7 to 0.21, that's 0.91. So therefore, the gradient is 0.45 over 0.91, and working this out, we get a value of 0.4945, etc. And therefore, b is equal to 0.495 to 3 significant figures. Store this into b. We now need to find out the value of a, and we can do that by substituting this point here, minus 0.7 and 0. So if I substitute in the point minus 0.7, 0, we've got log base 10 of t, which is 0. This is equal to b, 0.4945, etc. Use the unrounded values. So let's just actually clarify this. We've got log base 10 of t, which is 0. Then we've got the value of b, which is 0.4945, etc. And then we've got the value of log base 10 of L, so that's minus 0.7, plus log base 10 of A. So if we rearrange, we've got this value times by 0.7, so that means log base 10 of A is equal to 0.346 etc. So a is equal to 10 to the power of 0.346, etc. So the value of a is equal to 10 to the power of this, which is 2.21, etc., which to three significant figures is 0.22. Knowing the values of a and b, we can therefore conclude what t is. T is equal to 2.22 times L to the power of 0.495. The values here are given to three significant figures. For part C, with reference to the model, we have to interpret the value of the constant a. Of course, the value of a represents the time taken for one swing of a pendulum of length 1 meter. Question number 11. Figure 4 shows a sketch of the graph with equation y equals the mod of 2x minus 3k. K is a positive constant. For part A, we have to sketch the graph with equation y equals f of x, where f of x is equal to k minus the mod of 2x minus 3k. We have to state the coordinates of the maximum point and the coordinates of any points where the graph cuts the coordinate axis. So to do this, let's first of all consider y equals the mod of 2x minus 3k, the graph over here. Now with this graph, the minus here suggests to us we need to reflect this. So if we reflect the graph, we have something looking like this, and then once we've reflected it, we need to translate it k units up. So we're expecting our graph to look like something as we see here. So let's just sketch that. So here is a quick sketch of the graph. Now if we go back to our original graph, the one that we see here, we can find the coordinates of the maximum, rather the minimum point. Of course, we can spot that the minimum point would have coordinates 3 over 2k, 0, and that's through the symmetry of a graph. Treat it like a quadratic. We've got 3 over 2k, 0. So the vertex of y equals the mod of 2x minus 3k is 3 over 2k, 0. And when x is equal to 0, y is equal to the mod of 0 minus 3k, which is 3k. So if we add this to our diagram, the coordinates here will be 0 across 3k up. Now, if we consider the vertex, the x coordinate of this vertex will remain the same because we're not translating in the x direction. So here, we still would have a vertex 3 over 2k, 0. And in terms of where it intersects the axis over here, well, when x is equal to 0, f of 0 is equal to k minus the mod of 0 minus 3k, which is k minus 3k, which is minus 2k. The coordinate here then is 0 minus 2k. We now need to find out the coordinates of where the graph intersects the x-axis. We can do that by setting f of x equal to 0. And if we do that, we've got k minus the mod of 2x minus 3k equals 0. So, the mod of 2x minus 3k equals k. Replacing the modulus signs with plus minus, we've got plus minus 2x minus 3k equals k. If I deal with the positive one, 2x minus 3k equals k. So, continuing to solve this, 2x is equal to 4k, x is equal to 2k. And if I deal with the negative, 3k minus 2x equals k. 2x is equal to 2k. X is equal to k. So if we go back to our diagram, we can add this in. We've got the coordinate here of k 0, and we've got a coordinate here of 2k 0. Hence the graph of y equals k minus the mod of 2k minus 3k is what we see here. Now for part B, we have to find in terms of k the set of values of x for which k minus the mod of 2x minus 3k is greater than x minus k, giving your answer in set notation. What we need to do here is find out the critical values. We can do that by replacing the inequality sign with an equal sign. Hence, for part B, if we replace the sign, the inequality sign with an equal sign, we have k minus the mod of 2x minus 3k equaling x minus k. So if we rearrange the mod of 2x minus 3k, that's equal to 2k minus x. So we move this to the left hand side and this to the right hand side, and we get this result as we see here. If we replace the modulus signs with plus minus, we got plus minus 2x minus 3k equals 2k minus x. Dealing with the positive, 2x minus 3k equals 2k minus x. Add x to both sides, we have 3x equals 5k. So therefore x is equal to 5k over 3. That's one of the solutions. And if we deal with the negative, we've got 3k minus 2x equals 2k minus x. Adding 2x to both sides, we end up with x equals, and then if I subtract 2k from both sides, we have x equals k. So what does that mean? Well, what it means is, if we sketch this graph, we have here the graph of y equals x minus k. Here we've got a coordinate of 0 minus k. When x is 0, y is minus k. We've got a solution here, k, x equals k, and we'd also have another solution here, x is equal to 5k over 3. Now, with that, we need to find out where k minus the mod of 2x minus 3k is greater than x minus k. In other words, we're looking at where the red graph is greater than the green graph. Quite simply, that's in this region here. Hence, when we come to state the solution, we have k, which is less than x, which is less than 5k over 3. We need to express this in set notation, and if we were to express this in set notation, x belongs to a set of real numbers, and then we simply copy out our inequality as we see here. Alternatively, we could write this as x belonging to a set of real numbers, x is less than 5k over 3, or x belongs to a set of real numbers, x is greater than k. Now, for part C of the question, we have to find in terms of k the coordinates of the minimum point of the graph with equation y equals 3 minus 5 lots of f of 1/2 x. Well, if we take a look at our diagram, rather here, we've got k, because we've translated k units up. If we take a look at our diagram, the maximum of y equals f of x is 3 over 2k, k. So we can spot that from this graph. Of course, we've translated k units up, which is why we have the k for the y coordinate. Now, what we're doing here, we've got 3 minus 5 lots of f over 1/2 x. So, the minus suggests to us we're going to reflect it at some point. So, the minimum, because of course we've reflected, this suggests to us we are going from a maximum to a minimum. The minimum of 3 minus 5 lots of f over 1/2 x, well, the 1/2 x suggests to us we need to stretch by scale factor 2. Let's just write that down. We have to stretch scale factor 2 in the x direction. So, multiplying 3 over 2k by 2, we would have 3k for the x coordinate of the minimum, and for the y coordinate, we multiply k by minus 5 and then add 3. So we have 3 minus 5k for the y coordinate of the minimum of this. Question number 12. For part A, we have to use the substitution u equals 1 plus square root x to show that the integral from 0 to 16 of x over 1 plus square root x with respect to x is equal to the integral between p and q of 2 lots of u minus 1 all cubed over u with respect to u, where p and q are constants to be found. Our aim is to transform this integral in terms of x to an integral in terms of u. For part A, we begin with u equaling 1 plus square root x. When x is 0, u is equal to 1 plus square root 0, which is 1. And when x is 16, u equals 1 plus square root 16. 1 plus 4 is equal to 5. What we can also do is rearrange for x. If we were to rearrange for x is equal to u minus 1 all squared. What we also need to do is replace dx with something involving du's. If we find out what dx over du is, differentiating using the chain rule, we end up with 2 lots of u minus 1, and so therefore dx is equal to 2 lots of u minus 1 du. We now have enough information to transform the integral. So therefore, the integral from 0 to 16 of x over 1 plus square root x dx, that's equal to the integral from 1 to 5. Now x, we've said, is u minus 1 squared. On the bottom, we've got 1 plus square root x, which we said is u. We will then multiply this by dx, which we said is 2u minus 1, and then we will multiply this by du. So that can all be tidied up to the integral between 1 and 5 of 2 lots of u minus 1 cubed, u minus 1 all squared, times u minus 1 is u minus 1 all cubed. And then we divide this by u, and we are integrating with respect to u. Now, for part B of the question, ensure that the integral from 0 to 16 of x over 1 plus square root x with respect to x is equal to a minus b times the natural log of 5, where a and b are constants to be found. For part B, what we will do to begin with is consider u minus 1 all cubed. If we expand this using the binomial expansion, we've got 1 lots of u to the power of 3 times minus 1 to the 0 plus 3 lots of u squared times minus 1 to the 1 plus 3 lots of u times minus 1 squared plus minus 1, plus 1 lots of u to the 0 lots of minus 1 cubed. So what we end up with here, if we tidy all of this up, is u cubed minus 3u squared plus 3u minus 1. And so therefore, the integral of 2 lots of u minus 1 all cubed over u du between 1 and 5, that's equal to the integral from 1 to 5 of 2 lots of, well, we'll take the 2 outside instead, and then we've got u cubed minus 3u squared plus 3u minus 1 over u du. So we've got 2 lots of the integral between 1 and 5, u cubed over u, that's u squared. Then we've got minus 3u plus 3 minus, well, here we've got minus 1 over u. And then we are integrating with respect to u. So, if we work all of this out, we've got 2 lots of, well, integrating u squared, we end up with u cubed over 3. Then here we've got 3u over 2, well, 3 over 2u squared, plus 3u minus natural log of the mod of u. So we need to work out this entire result in between 1 and 5. So we've got 2 lots of, if I substitute in for my upper limit, we've got 5 cubed over 3 minus 3 times by 5 squared over 2 plus 3 times by 5 minus natural log of 5. So that's what we get for our upper limit. For our lower limit, we have 1 cubed over 3 minus 3 times by 1 squared over 2 plus 3 times by 1 minus natural log of 1. Well, natural log of 1 is just 0. So if we continue to work all of this out, we've got 2 lots of, well, let's tidy all of this sum up. We have here 5 cubed over 3 minus 3 times by 5 squared over 2 plus 3 times 5 so that's 115 over 6 minus natural log of 5, and then we've got 1 cubed over 3 minus 3 over 2 times 1 squared plus 3 lots of 1. So then we subtract 11 over 6. So 115 over 6 minus 11 over 6, that's 52 over 3, and then if I multiply that by 2, we get 104 over 3 minus 2 times by the natural log of 5 as our final answer. So therefore the integral between 0 and 16 of x over 1 plus square root x dx is equal to 104 over 3 minus 2 times by the natural log of 5. Question number 13. The curve C has parametric equations x equals sine 2 theta and y equals cosec theta cubed, where theta is in between 0 and pi over 2. For part A, we have to find an expression for dy over dx in terms of theta. Well, if we were to differentiate x with respect to theta, you will find dx over d theta to equal 2 cos 2 theta. And if we were to differentiate y with respect to theta, well, we can rewrite y as cosec theta all cubed. So if we use the chain rule, we would end up with 3 lots of cosec squared theta. Rather, let's just write this out as cosec theta squared. And then we need to multiply by the derivative of cosec theta. Now if we go to the formula book, to the differentiation section, the derivative of cosec theta is minus cosec theta cot theta. So we'd have a minus here, and then we multiply this by cosec theta cot theta. In other words, we end up with minus 3 cosec cubed theta cot theta. And so therefore, to find out what dy over dx is, that's equal to dy over d theta over dx over d theta, and that's through the chain rule. So we've got minus 3 cosec cubed theta cot theta divided by 2 cos 2 theta. We can leave our answer like this, there's no need to simplify. For part B, hence find the exact value of the gradient of the tangent to C at the point where y equals 8. Well, what we need to do is find out the corresponding theta value. Now, when y equals 8, we have cosec cubed theta equals 8. So, recognizing that cosec is the same as 1 over sine, cosec cubed is the same as 1 over sine cubed. So we've got 1 over sine cubed theta equals 8. Sine cubed theta is equal to 1/8, from which we can see sine theta is 1/2, and therefore theta is equal to pi over 6. And recognizing that theta is equal to pi over 6, we can therefore conclude dy over dx, we have minus 3 cosec cubed of pi over 6 times by cot of pi over 6 over to cos of 2 times by pi over 6. So if we work all of this out using our calculator, first of all make sure we are in radians. Key in pi over 6. Now we've got minus 3 over cosec cubed, so this is the same as sine of pi over 6 cubed, and then we multiply this by cot. Cot is the same as 1 over tan, so we've got 1 over tan of pi over 6, and then on the bottom we've got 2 lots of cos of 2 times by pi over 6. It turns out we get minus 24 times by the square root of 3. Question number 14. Water flows at a constant rate into a large tank. The tank is a cuboid with all sides of negligible thickness. The base of the tank measures 8 meters by 3 meters, and the height of the tank is 5 meters, and there's a tap at the point T at the bottom of the tank. All this is shown in figure 5. At time t minutes after the tap has been opened, the depth of water in the tank is h meters, indicated here. Water is flowing into the tank at a constant rate of 0.48 meters cubed per minute. Water is modelled as leaving the tank through the tap at a rate of 0.1 h meters cubed per minute. For part A, we have to show that according to the model, 1200 dH over dt is equal to 24 minus 5h. So, to begin with, let's think about what we know. We know that the flow rate in is 0.48 meters cubed per minute. Think about the dimensions here. Meters cubed per minute, that suggests we've got a volume over time. So that suggests the flow in is 0.48, the flow out is 0.1 h, and so therefore, with that information, you can see we've got dV over dt, the rate of change of volume with respect to time. This is equal to what's going in, 0.48, minus what's going out, 0.1 h. The units for this, we've got meters cubed per minute. So this is what dV over dt is. How does that help us? Well, let's think about what we've got here. We've got a dH over a dt. Here we've got a dV over a dt. In our show that, we've got something which doesn't involve volume. So we need to get rid of volume, and one way we can do that is to use the chain rule. If we think about what dH over dt is, with the chain rule, the chain rule would suggest to us, well, in our show that we've got a dH over a dt. And what else do we have? We've been given a dV over a dt. Well, we've worked it out. So what we need essentially then, to work out what dH over dt is, we need a dH over a dV. Can we work that out? Well, after t minutes, how much water would we have in the tank? So, let's just write that down. After t minutes, dV over dH, the rate of change of volume with respect to the depth, that's going to equal 8 times 3 times h. In other words, after t minutes, the volume in the tank is given by, well, the volume in the tank, V, that's equal to 8 times by 3 times by h. We've got 24h meters cubed. So therefore, the rate of change of volume with respect to the depth is equal to 24 meters cubed over meters. And so therefore, dH over dV, this is equal to 1 over 24 meters over meters cubed. So therefore, dH over dt, using the chain rule, we've got dV over dt, which is 0.48 minus 0.1h. Of course, here the units would be meters cubed per minute. And then dH over dV, that's 1 over 24 meters per minute, meters per meters cubed. This and this cancel, so we are left with 0.48 minus 0.1h over 24 meters per minute. So this is what dH over dt is. Now, if we pay attention to what we want to show, well, if I divide this through by 1200, 24 divided by 1200, that's 0.02, and then 5 divided by 1200, that's 1 over 240. So we need to somehow show that this is equivalent to this. So what we want on the bottom is 1200. How do I go from 24 to 1200? When I multiply through by 50. So 50 times by 0.48 is 24. And then over here, 50 times 0.1, that's 5. And so therefore, we have 1200 dH over dt equals 24 minus 5h meters per minute. And that's exactly what we wanted to show. Now, part B, given that when the tap was opened, the depth of water in the tank was 2 meters, we have to show that according to the model, h equals a plus b e to the power of minus kt, where a, b and k are constants to be found. Well, what we need to find is h essentially, and we've been given a condition. The depth of water in the tank is 2 meters. That's when the tap was opened. So this entire sentence would suggest to us that when t equals 0, h is equal to 2. We've been given a condition. What we have here is a differential equation. We need to find out what h is. Let's begin by separating the variables. If we separate the variables, we've got 1200 over 24 minus 5h. This is equal to 1. So, if we then integrate, we have the following integral, the following differential equation. 1200 over 24 minus 5h dh equals the integral of dt. So, if we integrate, we have t equals minus 240 times by the natural log of the mod of 24 minus 5h plus c. And if we use the condition t equals 0, h equals 2, we've got 0 equals minus 240 times by the natural log of 24 minus 10 plus c. So we've got 0 equals minus 240 times by the natural log of 14 plus c. In other words, c is equal to 240 times by the natural log of 14. So, we can therefore conclude t is equal to 240 times by the natural log of 14 minus 240 times by the natural log of the mod of 24 minus 5h. And what we need to do is rearrange for h. So, if we simplify this even further, we've got t equals 240 times by the natural log of the mod of 14 over 24 minus 5h and then we need to rearrange for h. So if we divide through by 240, we've got t over 240 equals natural log of the mod of 14 over 24 minus 5h. If we antilog both sides, we have e to the power of t over 240. This is equal to 14 over 24 minus 5h. So if we rearrange, 24 minus 5h equals 14 over e to the power of t over 240. 24 minus 5h equals 14 e to the power of minus t over 240. And so we can therefore conclude h is equal to 24 over 5 minus 14 over 5 multiplied by e to the power of minus t over 240. And now for part C of the question, given that the tap remains open, we have to determine, according to the model, whether the tank will ever become full, giving a reason for your answer. Now here, when h is greater than 24 over 5, if we take a look at what the volume's like, dv over dt, well, let's just substitute any value in greater than 24 over 5. So let's just say it's 4.85, for example. 0.48 minus 0.1. What's of this? Well, it seems as though dv over dt is going to be less than 0. So we can say then that dv over dt is less than 0. Let's just go back to the question. It's saying that, will the tank ever become full, giving a reason. The tap remains open. So as long as h is greater than 0.48, we're saying that the rate of change is going to be negative. So, according to the model, the limit for h is 24 over 5, which is 0.48 meters. So, we know already that the tank is 5 meters high. We're saying that the height when the tap's open is 24 over 5, so the tank will never become full, because this value, this is 4.8 rather. So because this value is less than the 5 meters, the tank will never become full. Question number 15. For part A, we have to express 2 cos theta minus sin theta in the form r cos of theta plus alpha, where r is greater than 0 and alpha is in between 0 and pi over 2. We have to give the exact value of r and the value of alpha in radians to 3 decimal places. Well, if we take a look in the formula book, in the trigonometry section, we are told that we need to express this expression in the form r cos of theta plus alpha. So we need to use this result here. Of course, we've got a plus here, so we'd have to use the minus here. So, for part A, we've got 2 cos theta minus sin theta, which is equivalent to r times by cos theta cos alpha minus r sin theta sin alpha. And if we compare coefficients, comparing the cosine terms, you can see we've got 2 equals r cos alpha, and if we compare the sine terms, we have 1 equals r sine alpha. So therefore, tan alpha is equal to 1/2 dividing the equations. So therefore, alpha is equal to the inverse tangent of 1/2, which is 0.4636, etc. This is equal to 0.464 to 3 decimal places. And if we find out what r is equal to 2 squared plus minus 1 squared square rooted. So we have the square root of 5 for the value of r. And so therefore, we can conclude that 2 cos theta minus sine theta is equal to root 5 times by the cosine of theta plus 0.464, given of course to 3 decimal places. Now for part B, figure 6 shows the cross-section of a water wheel. The wheel is free to rotate about a fixed axis through the point C. The point P is at the end of one of the paddles of the wheel, as shown in figure 6. The water level is assumed to be horizontal and of constant height. The vertical height, h meters, of P above the water level is modelled by the equation h equals 3 plus 4 cos of 0.5t minus 2 sine of 0.5t, where t is the time in seconds after the wheel starts rotating. And using the model, we have to find the maximum height of P above the water level and the value of t when this maximum height first occurs, giving an answer to 1 decimal place. So far we know that h is equal to 3 plus 4 cos of 0.5t minus 2 of 0.5t minus 2 sine of 0.5t. So we have 3 plus 2 lots of 2 cos of 0.5t minus sine of 0.5t. What you can hopefully see from here, comparing this result here with what we have in part A, we can therefore conclude h is equal to 3 plus 2 root 5 of cos of, well here instead of us having a theta we've got 0.5t plus 0.464. So this is what h is equal to. So therefore, we can conclude that the maximum, well, let's just draw out the graph of cos. With the graph of cos, of course, the maximum of h, bearing in mind the transformations in the t direction, we then stretch it and then we add 3, so the max h is equal to 3 plus 2 root 5 meters. And then where this maximum value, the value of t for which this maximum occurs, well, what we need to do over here is recognize that the maximum would occur when the cosine of 0.5t plus 0.464 is equal to 1. And with the graph, we've got 0.5t plus 0.464 equals 2 pi. So what we need to do is find out what t is. So therefore t is equal to, well, we've got 2 pi, take away this, and then multiplying through by 2, we get 11.639, etc. So t is equal to 11.6 given to 1 decimal place. Now for part C, in a single revolution of the wheel, so what that means is 1 full turn, P is below the water level for a total of t seconds. So in 1 full turn, it's below water level for a certain period of time. And according to this model, we have to find the value of t, giving an answer to 3 significant figures. Well, it's below the water level. Well, what we can do actually is find out the range of values for which h is equal to 0. So, if we do that, when h is equal to 0, we've got 3 plus 2 root 5 times by the cosine of 0.5t plus 0.464 equals 0. So, the cosine of 0.5t plus 0.464 is equal to minus 3 over 2 root 5 so if we attempt to solve, well, first of all, we've got the inverse tangent of 0.5. Store this into our calculator. We've got 0.5t plus 0.464 equals, well, the inverse cosine of minus 3 over 2 root 5. That's equal to 2.306, etc. Store this into B, and then if we do 2 pi minus that, we also get 3.977, etc. So if we find out what t is, well, I need to take away the inverse tangent of 0.5t and then times by 2. So I've got 7.02, etc. Store that into A. And then for the other one, I've got the inverse cosine of minus 3 over 2 root 5 minus the inverse tangent of 0.5, and then if I times that by 2, I get 3.68, etc. So therefore, the time required that's equal to 7.02 etc. minus 3.68 etc. So I've got that minus this, which is 3.419 etc. So what are the units? Well, the units are in seconds, and we need to give the time to 3 significant figures. So we've got 3.341, well 3.34 given to 3 significant figures. And the units, of course, we've got seconds. Now for part D, in reality the water level may not be of constant height, and we have to explain how the equation of the model should be refined to take this into account. Well, of course, this 3 needs to vary. So the 3 would need to vary.